Hi everyone, this is Sir Marvin Bartido. So for today's topic here in Geotechnical Engineering 1, we're going to discuss the next topic under Atterberg limits, which is the shrinkage limit. So for this video class, we're going to discuss the concept of shrinkage limit and we're going to solve sample problems. So let's get this discussion started. Okay, so let's now talk about shrinkage limit. So soil shrinks as moisture is gradually lost from it. No? So explain natin yan class using this graph. Okay, so let's say class initially, yung soil natin, no, meron siyang initial water content. Okay, so itong soil natin na to class with initial water content, so meron din yan initial volume. Taba. So, plus itong graph na to, yung x-axis para ito sa moisture content ha. Tapos ito namang y-axis para ito dun sa volume ng soil. So, class, makikita mo dito na habang bumababa yung water content natin, okay, bumababa din yung volume. Tama. So, habang nawawala or nagkakaroon ng reduction, nagkakaroon ng decrease sa water content class nung soil natin, okay, what happens dun sa volume class? Lumiliit siya. Nag-shrink, no, yung volume ng soil natin. So, nagkakaroon ng decrease din class doon sa volume. Okay, so, class, yung continuous na loss ng moisture content na yan class, no, merong point yan class na marireach kung saan yung change dun sa volume natin class is na magi-stop na. Okay, so class yung point no wherein yung change ng volume natin class doon sa soil natin kahit pa bumaba pa yung water content niya ay hindi na magbabago. Class mangyayari yon dito sa point na to. Okay, so class itong point na to, this is the shrinkage limit. No, so this is the moisture content in percent at which the volume of the soil mass ceases to change. No, so that is the shrinkage limit. So from this point class, no, and then kahit na mag-decrease pa class yung moisture content hanggang maging dry yan, hanggang maging zero yung water content natin, class yung volume na yan class constant na. Okay? Hindi na siya mag-shrink pa, hindi na siya magde-decrease pa in volume. Okay, so class, from here, take note na from liquid limit hanggang shrinkage limit class, yung soil natin dito class ay fully saturated. Okay, so class, ibig sabihin walang walang air voids dito. Okay, so yung void lang natin dito is water. Since dito class, 'di ba, yung soil natin tawag dito, yung mga soil particles natin, 'di ba, they are surrounded by water. Kaya nga meron silang cohesive nature. No, so just take note of that. Okay. Okay, so from figure 4.11, the shrinkage limit can be determined as SL is equal to W sub I minus delta W. So yung SL class, yan yung notation natin para sa shrinkage limit. And then yung W sub I, this is the initial moisture content when the soil is placed in the shrinkage limit dish. And then yung delta W, this is the change in moisture content. That is between the initial moisture content and the moisture content at the shrinkage limit. So class, from the figure, yung initial water content natin from here papunta dito. No? And if we subtract this delta W class, ang makukuha natin ay ito. Wherein ito class, yung moisture content na to class, yan ay shrinkage limit. Okay, so this is our formula class ha. So sa mga succeeding slides natin, papakita natin class kung paano ba natin makukuha yung W sub I at saka yung delta W. Okay. Okay, so to solve for W sub I, we can use this formula. So this is W sub I is equal to M sub 1 minus M sub 2 over M sub 2 times 100. Wherein M sub 1, this is the mass of the wet soil pat in the dish at the beginning of the test. And then M sub 2, this is the mass of the dry soil pat. Okay, so class, basically, itong formula na to, this is just the same formula na ginagamit talaga natin class to compute water content. So that is just the mass or the weight of the water over weight ng soil solid or mass ng soil solid. Okay, so class, itong M sub 1 minus M sub 2, this is just actually mass nung wet soil, tas ito mass nung dry soil. So kapag ginawa mo yan, sinubtract mo yan class, edi mass ng water yung makukuha natin dyan. mass ng water over ito ay mass ng dry soil, or basically ito yung mass lang din ng soil solid natin. So mass ng water over mass ng soil solid, that is water content. Tama. So ganun lang din class yung pagkuha natin dito for W sub I. Okay, so class dito makita natin, no, ito yung ginagamit natin class na dish, no, in shrinkage limit test. Okay, so yan class ay initially nilalagyan yan class ng wet soil. Okay, and then i-dry siya, 'di ba? I-oven dry yan. So after siyang ma-oven dry class, ang nangyayari class doon sa volume nung soil natin class, nagsi-shrink siya, lumiliit siya. Taba. So ganun din class dito. Ito naman in real life ito, real life photographs ito. So ito class, no, ito yung wet soil natin, and after siyang ma-dry, makikita mo class na ano siya, lumiit siya, nag-shrink siya, 'di ba? Because of the loss of, kumbaga, nung water content, dahil nawala yung water content. Okay. Okay, now for the delta W class, so we can compute this using this formula. So delta W is equal to V sub I minus V sub F, quantity, times rho sub W over M sub 2 times 100. So class, take note na yung delta W natin, yan class ay difference ng initial moisture content natin, which is W sub I, at saka ng shrinkage limit natin. Okay, so difference yan ng dalawa na yan. So class, para malaman natin itong delta W na ito class, pwede nating i-incorporate yung volume. Okay, so class, sa initial water content natin or moisture content, okay, meron tayong initial na volume. So yung initial volume natin ay V sub I. Okay, and then dito class, sa may shrinkage limit natin, meron din tayong volume dito class. Ang volume natin dito, V sub F, no, or final volume. Ngayon class, di ba class, ang delta W, ito class ay change sa water content, change in water content. No, so ito class ay water content. So class, di ba sa pag-compute natin ng water content, dapat yan class ay mass ng water or weight ng water over mass or weight ng soil solid. Tama. So dito class yung M sub 2, wala na tayong problema kasi ito rin yung kanina, yung sa formula natin. Ito class ay mass nung dry soil. Tama. So dito class, dapat yung numerator natin, kailangan class ito ay mass ng water. In this case class, ito ay V sub I minus V sub F. So ito ay volume initial nung ano natin, nung wet soil natin, 'di ba? And then yung V sub F naman natin class, ito yung final volume, no, nung soil natin, no? So class, kapag kinuha mo yung difference niyan, V sub I minus V sub F, yan actually class ay volume ng water. Tama, this is actually volume ng water, no? And then class, kailangan nating gawing mass ng water, yung volume ng water na yun. So paano natin yun gagawin? So class, take note na yung density ng water or rho sub W, yan class ay mass ng water over volume ng water. Tama. So class, kung i-multiply natin yung volume ng water sa density ng water, ang makukuha natin class ay mass ng water. Tama. So basically class, itong formula natin dito sa numerator, ito class ay mass ng water. Tama. Ayan. Okay. So from here class, again, yung V sub I natin, okay, yung V sub I natin class, yan yung initial volume ng wet soil path. Okay, and then yung V sub F natin, that is the volume of the oven dried soil path. Okay, and then yung rho sub W natin, density yan nung water. So class, take note pala na dito kasi, no, ang ginamit natin na V sub F dito, 'di ba supposedly, ito class yung volume dito sa shrinkage limit. Tama, hindi yung volume doon sa zero na yung water content. Pero class, 'di ba nga, yung volume natin class mula dito sa shrinkage limit hanggang dito, na kahit maging dry siya, na wala ng water content, it will be constant. No, kaya class yung ginagamit natin na V sub F dito, no? So, since magiging constant lang yan from shrinkage limit hanggang maging zero yung water content niya, so yung ginagamit natin na V sub F dito ay volume ng oven dried soil path. Okay? Okay. So, plus kapag pinagsama na natin yung equation natin para dun sa W sub I at saka itong delta W, okay, so pwede na nating ma-rewrite yung pag-compute natin ng shrinkage limit this way. So, ang shrinkage limit natin class is SL, so that will be equal to m sub 1 minus m sub 2 over m sub 2 times 100 minus v sub I minus v sub f over m sub 2 times rho sub w times 100. Okay. So this is the formula for shrinkage limit. Okay, so class, for our formula for shrinkage limit, the first term, so this is actually water content, 'di ba? So class, kung paano natin kino-compute yung water content natin, so ganun lang din yung gagawin natin para dito, no? Okay, ngayon para dito sa second term, so meron tayong v sub I dito tsaka v sub f. So class, to determine the v sub I at tsaka v sub f, we have two methods that we can use. So the first one is the mercury method and the second one is the wax method. So yung una natin pag-uusapan, class, is yung mercury method. Okay, so the mercury method, class, this is in accordance with ASTM test designation D-427. So here, shrinkage limit tests are performed in the laboratory with a porcelain dish about 44 mm in diameter and about 12.7 mm high. So ito, class, yung example ng porcelain dish or shrinkage limit dish na ginagamit natin for this test. Okay, so class, yung ginagawa natin dito, the inside of the dish is coated with petroleum jelly and is then filled completely with wet soil. So ito, class, nilalagyan natin ito ng wet soil and pinupuno natin yan ng wet soil. But before we put the wet soil here, class, kailangan muna natin, class, lagyan ng petroleum jelly, no, yung inside nitong dish na ito. So the reason for that, class, is because kapag na-dry na natin, class, yung wet soil na yon, no, para hindi siya magdikit-dikit, 'di ba? Or hindi siya dumikit dun sa dish natin. No, yun yung reason kaya natin nilalagyan muna ng petroleum jelly. Okay. Ngayon, class, yung wet soil na yun, class, na nilagay natin sa dish, so titimbangin natin yun and ide-determine natin yung mass ng wet soil. So yung mass ng wet soil, class, yan yung magiging m sub 1 natin. And then after nyan, class, the soil pat in the dish is then oven dried. Okay, so class, i-oven dry, class, yung wet soil na nakalagay dun sa dish natin. And then after siyang ma-oven dry, class, i-determine, class, yung mass nung dry soil. So yung mass nung dry soil, class, yun yung magiging m sub 2 natin. Okay, ngayon, class, para dito sa v sub I, no, so pwede natin yan ma-determine using mercury method. So yung ginagawa natin, class, sa mercury method, okay, itong dish natin na to, no, class, we are going to fill this with mercury. No, so nilalagyan natin yan at pinupuno, class, ng mercury. So ginagamitan natin yan ng parang glass para i-press yung ano, no, yung ibabaw para lang, class, ma-strap off yung mga excess na mercury. Okay. So class, what we're going to do, class, yung volume nung mercury, class, na nandito sa dish na to, equal siya dun sa volume nung inside, no, or yung inside volume ng dish natin. Ulitin ko, class, yung volume nung mercury dito equal siya dun sa inside volume ng dish. And take note, class, na yung inside volume ng dish natin na ito, yun, class, ay equal din dun sa volume ng wet soil. Tama, kasi pinuno din natin ito kanina, tama ba, ng wet soil. So yung volume ng wet soil natin, equal lang siya dun sa may inside volume nito, nung dish na to. Okay, so class, yung volume na yun, class, yun yung V sub I. So sa madaling sabi, class, yung volume nung mercury dito, class, okay, equal siya doon sa initial volume. So yun yung gagamitin nating volume para dito. So para makuha natin, class, yung volume ng mercury, okay, we can use this formula. So this is mass nung mercury over density ng mercury. So class, ang gagawin lang natin dito, titimbangin natin ito. No, titimbangin natin to at i-determine natin yung mass ng mercury. And then ngayon, para dito sa density ng mercury. So class, di ba meron tayong formula na specific gravity? Yan, class, ay equal sa unit weight ng anumang substance or material over unit weight ng water. So pwede rin siya na density ng anumang substance or material over density ng water. So in this case, class, kung gusto nating kunin yung specific gravity ng mercury, so this is just density ng mercury over density ng water. And we know, class, na yung density ng water, yan, class, ay 1 gram per centimeter cube. Okay? And alam natin, class, na yung specific gravity ng mercury, that is actually 13.6. Tama? 13.6, class, yung specific gravity nito. So, ibig sabihin, class, yung density, class, ng mercury, yan ay 13.6 grams per cc lang. So, ito, class, yung gagamitin natin dito. no? Para dito sa density na to. Okay, so from here class, pwede na nating ma-determine yung volume ng mercury. So yung volume na makukuha natin dito, yun yung initial volume. Okay, now, for the final volume class, now what we're going to do here, the volume of the oven-dried soil pad is determined by the displacement of mercury. So class, ang ginagawa natin dito sa mercury method, gumagamit tayo ng another container, no, na filled din siya ng mercury. Okay, so what we're going to do class, yung oven-dried soil pad natin na galing dito sa step na to, tatanggalin natin yun class doon sa dish. So since nilagyan naman natin ng petroleum jelly yun class, hindi siya dumikit sa hindi siya dumikit sa dish natin. So buo nating makukuha class yung dry soil pad. Okay, and then class yung dry soil pad na yun class, ang gagawin natin doon, isa-submerge natin siya doon sa may container na merong mercury. No, so take note class ha, initially puno yan. Puno yung container natin ng mercury. So isa-submerge natin doon class yung soil pad natin. So class yan ay ginagamitan natin ng glass. So parang pinapress down natin yung dry soil pad natin para ma-submerge siya doon sa mercury. Kasi class, take note, ang mercury class sobrang dense yan. Tama, sobrang dense niyan. So, class, kung mapapansin mo, di ba yung density ng water, 1. Yung density ng mercury, 13.6. So, sobrang taas ng density niya. So, sobrang dense yan. So, class, yung soil natin, yung dry soil natin, kapag yan, class, ay nagkaroon ng contact doon sa mercury natin, class, hindi niyan i-absorb yung mercury. Kasi nga, sobrang dense ng mercury. Unlike sa water. Di ba, class, kapag yung soil, yung dry soil, kapag yan ay nilagyan mo ng water, diba? Ang nangyari, yung water na-absorb ng dry soil. So, in this case, class, yung mercury hindi niya ma-absorb. Kaya, class, mercury yung ginagamit natin dito. No, kasi nga, hindi naman niya ma-absorb or hindi ma-absorb nung lupa yung mercury. Okay, so pwede yan, class, ma-submerge. So, class, kapag yan ay pinrest down para ma-submerge sa mercury, what will happen is that merong amount of mercury na magi-spill. Diba? Merong mga tatapon, class, na mercury. So class, yung amount ng mercury na yan, yung volume ng mercury na yan, yan yung volume na na-displace nung oven-dried soil pad natin. At yan yung same volume nung oven-dried soil pad natin. Diba? Yung na-displace na yan ng mercury. So para malaman natin class yung volume nung na-displace na mercury, okay? So, class, kukunin natin yan, yung excess na yan, yung mga tumapon na yan. And then, titimbangin din natin yan, class. So, aalamin natin yung mass niyan. And then, yung mass niyan, class, gagamitin din natin tong formula na to. So, yung mass na nakuha natin, sa substitute natin dito. Tapos, ito, may value naman na tayo, ito. So, makukuha natin yung volume. Diba? So, yung volume na makukuha natin, class, na yun yung magiging final volume natin. Okay. So, yun yung ginagawa natin, class, dito sa mercury method para makuha yung V sub I tsaka V sub F. Okay. Okay. So, class, as we know, mercury is a toxic substance. So, if we are going to use mercury in shrinkage limit test carelessly, it could be dangerous to us. So, instead of using mercury method, class, here, now we can use an alternative method, no, cold wax method, wherein hindi na natin kailangan ng mercury. No, so itong method na ito, class, this is in accordance with ASTM test designation D-4943. So this test designation describes a method where volume V sub I is determined by filling the shrinkage limit dish with water. So yung ginagawa natin dito, class, instead na mercury yung gagamitin, water yung gagamitin natin. So if i-fill lang natin, class, yung dish natin with water, okay, and then pupunuin yon, no, and then what we're going to do is determine the mass of that water, no, and then we're going to use this formula. So class, ang makukuha natin dito, class, ay volume ng water, di ba? Since water yung ginamit natin. So para makuha yung volume ng water, yun, class, ay mass lang ng water over density ng water. Wherein yung density, class, ng water, this is just 1 gram per centimeter cube. So, class, yung volume ng water na to na makukuha natin, yan, class, ay equal doon sa inside volume ng dish. Tama? And take note na yung inside volume ng dish, diba, equal lang din siya sa volume ng wet soil. So, therefore, yung V sub I natin, ito yung volume ng wet soil natin. So, that's how we determine, class, yung V sub I. Now, to determine V sub F, the dry soil pat is dipped in a molten pot of wax and cooled. Okay, so dito kasi class, ang ginagawa natin or gagawin natin, yung dry soil pat, no, isa-submerge din siya class sa water. Okay, katulad sa kanina, 'di ba kanina sa mercury natin sinubmerge yung dry soil pat natin. But in this case, class kapag in-imagine mo na kapag yung dry soil natin, sinubmerge natin 'yan sa water, class ang mangyayari doon, yung soil natin, maa-absorb niya lang yung water. Tama. So, instead na ganun yung gawin class, ang kailangan natin gawin dito class, kailangan muna natin i-dip in a molten pot of wax. Or kailangan mabalutan muna class ng wax yung ano natin, yung dry soil natin. No, so after class na ma-dip in a molten pot of wax at ma-cool, okay, yung dry soil pot natin, dun natin siya pwedeng ma-submerge. Kasi class, yung wax, yung purpose niya is para mapigilan na mag-penetrate yung water doon sa dry soil. Okay? So, class, the mass of the dry soil and wax is determined in air and in submerged water. Okay. So, class, kailangan nating malaman kasi dito, no, yung volume ng water na na-displace ng dry soil. Tama? Kasi yun yung magiging volume din ng dry soil. So, para malaman natin yung volume na na-displace, plus kailangan muna nating i-determine yung mass ng water na na-displace. 'Di ba? Nung dry soil pat at saka nung wax. So, may wax tayo na kasama dito ha. So, hindi lang siya dry soil. So, madedetermine natin class yung mass nung water na na-displace ng dry soil pat at saka ng wax, no, by using this formula. So, this is m sub 5 is equal to m sub 3 minus m sub 4. Okay, so yung m sub 5, again, yan class yung mass ng water displaced by dry soil pad and wax. And then yung m sub 3 class, yan yung mass of dry soil pad and wax in air. So yan yung timbang class lang, no? Timbang nung ano natin, nung dry soil pad natin tsaka wax. So titimbangin mo lang yun. So yun yung magiging m sub 3. And then yung mass of dry soil pad and wax in water naman. So what we're going to do class, in a separate container. So meron tayong field ng water yun class. Okay, so class ang mangyayari, titimbangin yon yung mass ng water doon. And then after nun, isa-submerge natin class yung dry soil pat and wax doon sa water na yon. Okay, and then titimbangin din yon. So yung timbang ng class, isusubtract doon yung mass ng water. So kapag sinubtract natin yung mass ng water doon, ang makukuha natin class is mass of dry soil pat and wax in water. Okay, so ito yung m sub 4. No? So, yung m sub 3 minus m sub 4 nga class, yan yung magiging m sub 5 natin. Okay. Now, para naman class doon sa volume ng dry soil pat and wax, no, it can be calculated. So, since meron tayong mass ng dry soil pat at saka wax natin, so pwede natin yan gamitin. So, that is just ulitin ko ha, yung volume class ng water displaced by dry soil pat and wax, equal lang yan sa mass ng water displaced by dry soil pat and wax over density ng water. So again, yung density ng water dito, 1 gram per centimeter cube lang yan. So yan yon yung para sa volume ng dry soil pat and wax. Okay, ngayon class, since yan ay volume ng dry soil pat and wax, kailangan natin class ibawas dyan yung volume ng wax. 'Di ba, na ginamit natin. Kasi ang kailangan lang natin diyan yung volume nung dry soil. Tama? So, class, ang mangyayari, kailangan muna nating i-determine yung mass ng wax. So, yan ay magiging m sub 6. So, pwede natin yan ma-obtain class by subtracting from m sub 3 yung m sub 2. Yung m sub 3 natin, class, ito yon, yung mass ng dry soil pat and wax. Yung m sub 2 natin, mass ng dry soil. So, makukuha natin dito yung mass ng wax. Okay, and then, kailangan din nating alamin yung volume ng wax class. So, pwede natin yan ma-determine by this formula. So, wax ito ha. So, volume ng wax. So, ito class ay mass ng wax. So, dito, kailangan natin yung density ng wax. Now, wherein yung density ng wax class yan ay equal sa specific gravity ng wax times density ng water. No? Ayan. So, from here class, pwede nating malaman yung V sub F. So, ito yung volume ng water na na-displace ng dry soil pat, wherein yun ay equal din sa volume ng dry soil pat. No? So, ito class ay equal sa volume ng dry soil pat and wax minus volume ng wax. I na class yung magiging V sub F natin. So that's how we determine V sub I and V sub F using wax method. Okay, so class, I'll be giving you an additional formula in solving for the shrinkage limit. So, this will be useful, class, depende dun sa given sa problem. So, ito, class, another formula for shrinkage limit. This is equal to V sub F over M sub S minus 1 over rho sub S, quantity, times rho sub water, or W, times 100. Okay, so class, itong V sub F na to, so this is the same volume dito. So, ito class yung volume nung dried soil natin. Okay, and then yung M sub S class, actually ito class ay M sub 2. No, yung M sub S na to. Ito class ay mass nung dried soil. And then itong rho sub S, ito class ay density nung soil particles natin. Okay, tas yung rho sub W, so yun ay ano lang din, density lang din yan ng water. So ito class, we can derive this, no, from this formula. So, dito kasi class, no, paano kung ito lang yung mga given sa problem natin? 'Di ba? So, ito class, hindi nito na kumpleto yung mga given para dito. Tama. So, kailangan class, kapag ito yung given, ito yung gagamitin natin class. 'Di ba? Na formula for shrinkage limit. And, so class, we can derive this, no, from this original formula. Okay. So, class, yung ano natin, di ba yung M sub 1 minus M sub 2, this is actually mass ng water. Tama? Since yung M sub 1, mass yan ng wet soil, tapos ito, mass ng dry soil. So, mass ng wet soil minus mass ng dry soil, mass ng water yon. Tama? And then yung M sub 2, alam natin, mass yan ng soil solid lang. Di ba? Or mass ng dry soil. And then, dito, class, ang ginawa natin, inilabas natin dito class yung V sub I over M sub 2. No, so kapag inilabas natin yan class, yan ay V sub I over M sub 2 times ito, rho sub W, tas naka-negative. Tama, so inilabas natin yan class dito, so magiging negative V sub I over, plus yung M sub 2 na yan, yan ay M sub S din, mass ng dry soil, tama. Over, or times, rho ng water or density ng water, no, times 100. No, so yung naiwan na lang dyan class, negative times negative, V sub F, magiging positive yon. Over M sub 2, which is M sub S din yan. And then times rho ng water, times 100. So magiging ganito siya. Ngayon class, di ba, yung V sub I natin, ito. Class, di ba ang V sub I natin, ito ay volume ng wet soil. Tama? So, volume ng wet soil. Eh, di ba ang volume ng wet soil class natin dito, yun ay volume ng soil solid, tsaka volume ng water. Tama? So, take note dito, class, saturated ang soil natin, ha? Nabanggit natin yan. Okay, so, class, yung volume sub I na yan, or initial volume, yan ay volume ng soil solid plus volume ng water. And also, class, yung mass ng water natin, class, pwede natin ito gawing in terms of volume. Diba? By this formula. Diba? So, density kasi ng water, mass yan ng water over volume ng water. So, therefore, yung mass ng water, volume lang yun ng water times density ng water. Tama? So, from here, class, pwede nating i-distribute to. No? Ito. Okay. So, magiging, ano yan? V sub S times rho sub W. Ito. Tapos ito din, V sub W times rho sub W. So, naka-negative yan, ha? Okay. So, ang mangyayari, ito na yung magiging simplified. So, pwede nating gawing one fraction lang to. So, common denominator nila yung M sub S. So, ang mangyayari dito, class, makakancel yung V sub W times rho sub W. No, makakancel to, tsaka to. So, yung matitira dito, class, ay ayan, negative V sub S times rho sub W over M sub S. No, times 100, tapos ito. No, so dito class, di ba class, ang M sub S over V sub S, yun ay density ng soil solid. Tama? So ito, nagbaligtad kasi ito, so reciprocal. So yung mangyayari lang, it will become negative 1 over rho sub S. Wherein itong rho sub S nga, density yan ng soil particles. Diba? Ayan. So ganito class yung mangyayari sa formula natin. So kapag i-simplify pa natin ito class, no? So pwede natin class pagsamahin yung dalawa. So, V sub F over M sub S, tas meron sila parehong rho sub W. So, pwede natin i-factor out, tsaka yung 100. So, ito class minus 1 over rho sub S. So, dito yan ang galing class. No, yung formula na ito. And so, this will be useful kapag ang given natin class ay ito. Okay, anyway. Okay, so let's now talk about shrinkage ratio. So this is a parameter class that we can determine from shrinkage limit test. Okay, so shrinkage ratio, this is the ratio of the volume change of soil as a percentage of the dry volume to the corresponding change in moisture content, or ito yung class. So yung SR class, yan yung notation natin for shrinkage ratio. So again, from the definition, yan class ay ratio ng volume change of soil. So ito yung volume change of soil as a percentage of the dry volume. So, ito yung dry volume over the corresponding change in moisture content. So, ito class yung change in moisture content. So, ito ay change dun sa mass ng water, no? Itong delta M. Tapos, itong M sub 2, yan class yung mass ng dry soil, no? Tama. Okay. So, from here, class, itong change in mass of water, no? So, ito ay change in mass of water. So, pwede natin siya class i-rewrite as delta V times density ng water. Tama. So, from here, pwede natin makancel yung delta V. And then, ang mangyayari dito, means extreme. So, itong M sub 2 mapupunta sa itaas. Tapos, itong V sub F, mamumultiply dito. No? So, ang mangyayari class, M sub 2 over V sub F times rho sub W. So, ito class yung formula natin for shrinkage ratio. So, this is mass nung dry soil, V sub F, volume ng dry soil, and then itong rho sub W, density lang yan ng water. Okay. So, from here, class, also, class, we can show, no, or it can also be shown that G sub S equal to 1 over SR minus SL over 100. So, class, kapag meron tayong shrinkage ratio tsaka shrinkage limit, pwede nating ma-solve, class, yung specific gravity ng soil solid. Okay, okay. So, yung SR pala dito, class, or shrinkage ratio, so this is not in percent, ha? So, this is in decimal number, yung SR. And then, yung SL, ito, class, ay percentage, no? Kaya dinidivide ito sa 100 dito. Okay. Okay, so class, we also have what we call volumetric and linear shrinkage. So if desired, kung gusto natin class na ma-solve yung volumetric shrinkage at saka linear shrinkage, no, at a given moisture content, no, so pwede natin gamitin tong formula na to. So para dun class sa may V sub E or VS or volumetric shrinkage, and class ay equal sa shrinkage ratio times water content in percent minus SL. So, SL shrinkage limit. Okay, and then para naman class dun sa linear shrinkage, okay, so yan ay LS. So, equal yan sa 100 times quantity 1 minus quantity 100 over VS. So, yung VS class ay volumetric shrinkage. So, in percent yan, plus 100, and then naka-quantity yan, raised to 1/3. Okay. So, dito class, ito ay linear shrinkage. Okay. So, typical values of shrinkage limit for some clay minerals are as follows. So, ito class yung mga minerals, no, different minerals or clay minerals, and then yung corresponding shrinkage limit nila. So, Montmorillonite, yan class ay 8.5 to 15 yung shrinkage limit. I-lite or E-lite or E-lit, yan ay 15 to 17. Kaolinite, yan ay 25 to 29. Okay, so let's start solving sample problem number 1. Following are the results of a shrinkage limit test. Initial volume of soil in a saturated state equal to 24.6 centimeter cube. Final volume of soil in a dry state equal to 15.9 centimeter cube. Initial mass in a saturated state equal to 44.0 grams. And then for the final mass in a dry state equal to 30.1 grams. So determine the shrinkage limit of the soil. So for our given here class, so ilatag lang natin yung mga given natin. So meron tayong V sub I na 24.6. Ito yon yung initial volume ng soil. And then meron tayong final volume ng soil, no? So 15.9 centimeter cube. And then yung initial mass niya class, yan yung wet soil natin, 44 grams. And then para dun sa dry soil natin, yung mass class ay 30.1. So yan ay M sub 2. M sub 1, ano to ha, wet soil. And then class, for this problem, no, so we're going to solve the shrinkage limit. So yung formula natin for shrinkage limit ay ito. So actually, isa-substitute lang natin yung mga given natin. Meron tayong M sub 1, M sub 2, meron tayong V sub I, at V sub F. Okay, so substituting the values here. So yung M sub 1 natin, yan ay 44. Yung M sub 2 natin, 30.1. So 30.1 din yung denominator. And then V sub I natin, 24.6. V sub F, 15.9. And then M sub 2, yan din yun, 30.1. And then plus yung density ng water natin, take note na yung density class ng water ay 1,000 kg per meter cube. Or kapag kinonvert mo yan class, 2 grams per centimeter cube, yan ay 1. So yung kailangan natin class ay 1 gram per centimeter cube. Kasi class yung mga given natin dito ay grams at saka centimeter cube. No, so we should use 1, no, gram per centimeter cube para dito sa density ng water. So times 1 ito, ayan. And then 100 times 100. So solving this class, so the shrinkage limit therefore is 17.28%. So this is already the answer for number 1. Now for sample problem number 2, refer to sample problem number 1. Determine the shrinkage ratio of the soil. Also estimate the specific gravity of the soil solid. So from sample problem number 1, class, na-solve na natin yung shrinkage limit. Yan ay 17.28%. So kakailangan din natin yung mass ng dry soil, which is 30.1 grams, and yung volume ng dry soil, which is 15.9 centimeter cube. Okay, so from here, class, we have to determine yung shrinkage ratio at saka specific gravity. So for the shrinkage ratio, class, ito yung formula natin. Yan ay M sub 2 over V sub F times rho sub W. So yung M sub 2, yan yung mass ng dry soil, which is 30.1. Yung V sub F natin, yan yung volume ng dry soil natin, which is 15.9 centimeter cube. So yung density ng water natin dito, class, 1 gram per centimeter cube dapat ha, since yung mass natin ay grams, yung volume natin ay centimeter cube. Okay, so solving this, class, so yung shrinkage ratio natin ay 1.89. So yan na yung sagot, class, para sa shrinkage ratio. Now, for the specific gravity, ito yung formula natin for the specific gravity. So this is equal to 1 over SR minus SL over 100. So yung SR natin dito, ito na. And then yung SL natin in percent ay ito. So substitute lang natin. So class, solving the specific gravity, ang lalabas, class, ay 2.81. So this is already the specific gravity ng soil solid natin. Now, for sample problem number 3, again, we are going to refer to sample problem number 1. If the soil is at a moisture content of 28%, estimate the maximum volumetric shrinkage and the linear shrinkage. Okay, so to solve this, okay, so class, kailangan natin isolve yung volumetric shrinkage saka yung linear shrinkage. So yung mga given natin dito, class, is yung mga nakuha natin sa sample problem number 1. Yung shrinkage limit, 17.28%. And then yung shrinkage ratio, actually sa sample problem 2 natin ito nakuha, 1.89. So also given dito, class, yung water content, which is 28%. Okay. So from here, class, we are going to solve first the volumetric shrinkage. So ito, class, yung formula natin. So this is equal to SR times water content in percent minus shrinkage limit. So yung SR natin, given na yan, 1.89, yung water content 28. So it should be in percent ha. And then yung SL natin 17.28. So yung makukuha natin dito, class, na VS ay 20.26%. So yan na yung sagot, class, para sa VS. Ngayon, class, para dun sa linear shrinkage, okay, so ito, class, yung formula natin. So kailangan lang natin yung VS or yung volumetric shrinkage dito. So substitute natin yung nakuha natin na 20.26. So solving this, class, ang makukuha natin ay 5.96. So ito na, class, yung linear shrinkage. So, ito yung sagot para sa volumetric shrinkage. Ito yung sagot para sa linear shrinkage. Now, for sample problem number 4, during the determination of the shrinkage limit of a sandy clay, the following laboratory data was obtained. So, yung wet weight of soil plus dish is equal to 87.85 grams, dry weight of soil plus dish 76.91 grams, and then weight of dish equal to 52.70 grams. So, ito class yung mga weight no, na kailangan natin. And then class for the volumetric determination of soil path, ito na class yung mga given. Yung weight of dish plus mercury ay equal sa 430.80 grams. Yung weight ng dish ay 244.62 grams. So class itong mga binigay na weight dito class nung mercury. Okay, so ito class yung ano na ha, kumbaga ito na class yung volume nung mercury na na-displace nung soil path. No, since yung sabi dito volumetric determination ng soil path. Okay, so yung volume ng mercury na makukuha natin from this given, that is the volume of the mercury displaced no by the dry soil. Okay, so yun yung makukuha natin dito. And then given din class yung density ng soil solid which is equal to 2,650 kg per meter cube. So from this data class, we are going to compute the shrinkage limit of the soil, the shrinkage ratio, and the specific gravity of soil solid. So class, para dun sa shrinkage limit, di ba ang kailangan natin dito is yung mass ng wet soil at saka mass ng dry soil. Tama? So wala tayong problema doon, M1 at M2. Kasi pwede nating makuha yun dito sa data na to. Ano, kaya lang, yung V sub I, tsaka V sub F class, so yung V sub I, yun yung initial volume, no, nung wet soil, and then yung V sub F, yun yung final volume nung dry soil. In this case, class, ang ibinigay lang is yung volume ng mercury na na-displace nung dry soil. So, big sabihin, V sub F lang yung makukuha natin dito, class. No, so, sa madaling sabi, class, since hindi ibinigay, class, yung initial volume, no, yung V sub I na kailangan natin, hindi natin pwedeng gamitin yung original formula natin na merong M sub 1, M sub 2, tas V sub I, tsaka V sub F. No, so, in this case, class, ang gagamitin natin is yung ibinigay ko, class, na formula sa inyo, no, yung additional formula in solving for shrinkage limit. So, yung kailangan natin doon, class, is yung mass ng soil solid or yung mass ng dry soil. Wherein pwede natin itong masolve, class, by just subtracting ito. Subtracting from here yung 52.70, yung weight ng dish. So, yung weight ng dry soil plus dish, subtract lang natin yung weight ng dish, makukuha natin yung weight ng dry soil or yung mass ng dry soil. So, that will just be 76.91 minus 52.70. So, 24.21 grams, class, yung mass ng dry soil natin. So, kailangan din natin dito, class, yung final volume or yung volume ng dry soil natin. So, pwede natin makuha yung volume ng dry soil by determining the volume of the mercury displaced by the dry soil. So, dito yun, class, pwede natin kunin dito. Ayan. So, dito, class, pwede natin kunin yung mass ng mercury and then gagamitin natin yun sa pag-solve natin ng volume. Di ba yung pag-solve natin ng volume, class, let's say volume ng mercury, equal siya, class, sa mass ng mercury over the density ng mercury. So, in this case, class, yung mass ng mercury ay ito lang, subtract lang natin, 430 minus 80. Ito yung mass ng dish plus mercury. Tapos, subtract natin ito, 244.62, which is the mass of the dish. Para makuha natin yung mass ng mercury. So, ito yun, class, yung mass ng mercury. 430.80 grams minus 244.62 grams. Over, class, yung density ng mercury ay 13.6 grams per centimeter cube. Ha? So, makukuha natin yung volume dito. So, solving the volume of the mercury displaced by the dry soil. So, ito, class, ay 13.69 centimeter cube. So, this is the same volume, class, nung dry soil natin. No? And then, given din, class, yung density ng soil solid, which is kailangan natin yan dun sa formula natin. So, class, ito ay density ng soil solid. No? So, ang mangyayari, class, ito ay rho sub S, so 2,650 kg per meter cube. So, class, yung mga units kasi natin dito, gram at saka centimeter cube. No? So, kailangan natin to i-convert into gram per centimeter cube. So, converting this 2 gram per centimeter cube, it will become 2.65 grams per centimeter cube. So ito na, kompleto na class yung mga given natin para dun sa formula. So ito class yung formula natin, yung alternative formula natin. So SL is equal to V sub F, given yan. M sub S, given yan. 1 over rho sub S, given yan. Rho sub water, so yan naman, alam natin yung value niyan, times 100. So substitute lang natin mga values. So again, V sub F, 13.69 centimeter cube. M sub S, 24.21 grams minus 1 over 2.65. Okay, gram per centimeter cube yan ha. Ito. Yung density ng soil solid. And then yung 1 is density yan ng water. 1 gram per centimeter cube times 100. Okay, so computing this class, ang lalabas dito ay 18.81%. So this is already the shrinkage limit. Now, for the shrinkage ratio, so class yung formula natin dito ay ito. Now, so yung M sub 2 natin class, yan lang yung mass ng dry soil natin, which is ito naman. Nakuha na natin yan. V sub F, meron na rin tayo niyan. Density ng water, alam din natin yung value niyan. So yung M sub S, 24.21, 13.69 V sub F, tas yung density ng water, 1. Okay, so therefore class, ang shrinkage ratio natin ay 1.77. Now, for the specific gravity of soil, class, pwede natin gamitin tong formula natin, no, na involve yung shrinkage ratio tsaka shrinkage limit. Since meron tayong value ng shrinkage ratio tsaka shrinkage ng limit. So, pwede natin i-solve directly yung specific gravity. So, i-ano lang natin, class, i-substitute yung mga values. Okay, so yung magiging specific gravity natin dito, class, ay 2.65. Pero actually, class, pwede rin natin, class, gamitin yung binigay na density ng solid soil, no, sa pag-solve ng specific gravity. So, we know na yung specific gravity, class, equal lang siya sa density ng soil solid over density ng water. Alam natin, class, na yung density ng water, kapag kilogram per meter cube, 1,000 kilogram per meter cube. So, yung mangyayari, 2,650 over 1,000 lang yan. So, yan, class, ay 2.65. Okay, so these are already the answers, class, for this problem. That ends our discussion for this topic. I hope that you learn. Aral pa tayo mabuti, class. See you again sa next video discussion. Bye-bye.